right, so this is fifth grade math lesson 26, and I am excited because we're starting fractions. I love to teach fractions. I am a good fraction teacher. I am just here to tell you. So if you've ever struggled with fractions, if you will go into learning fractions with me with an open mind and let me teach you, then you will be able to learn fractions really well and you will love them and you'll be so excited because you will feel so smart. But if you go into this endeavor, I don't understand fractions, I never get them, I just can't do them, then that's what you're going to get, okay? Because you already have your mind made up. So if you will hear me when I say, I am a good fraction teacher, you will understand. If you will listen and if you will let me teach you, then you will understand fractions. I can promise you that. If I had a money back guarantee, I could guarantee it, but you would have to do your part, okay? All right, so when we have fractions, we know that our top number is called the numerator. I will use that term often, so if you do not know that the top number is a numerator, then you need to know that today. The top number of our fraction is a numerator, and the bottom number of our fraction is the denominator. And then the bar separating our numerator and denominator is a fraction bar. That is a fraction bar. And something that's really cool, I'll always tell you that for a little bit. I'll tell you that part later. But that is a fraction bar. So you have your numerator, fraction bar, denominator. So in our fraction, the numerator tells us the equal parts of something that is used. And the denominator tells us the total number of equal parts that we have. So let me just show you something. If we have this, and I draw this circle, and I divide it like that, can I say that that is 1/2? Because there's one part used, and there was two parts altogether. So can I say that that's 1/2? Why can't I? Because it's not 1/2. Because if I've split my candy bar or my pizza or whatever that I really like with somebody, I would like to give them that much and say it's 1/2, but it's really not. Because 1/2 would be 2 equal parts. Now that is 1/2. So anytime you're talking about fractions, you are talking about equal parts. Whether you're talking about the numerator or whether you're talking about the denominator, they are equal parts. Also, what you have to realize about fractions is when we're talking about fractions, we can talk about a whole, like a whole rectangle, or we can talk about a group of things. Like in my rectangle right here, I tried to make them look perfectly equal. Just pretend they are perfectly equal. I have 1, 2, 3, 4, 5, 6, 7. I have 7 equal parts total, so that is my denominator, or my down number. It's the number on the bottom, down, denominator, okay? And then the parts used, I have 1, 2, 3, 4 parts used, so that is my numerator. So my fraction for this would be 4/7. Now look down here at my stars. How many stars do I have in total? 1, 2, 3, 4, 5, 6, 7. I have 7 stars in total. How many stars have I used? 1, 2, 3, 4. So my numerator is 4 because that is the part of my group that was used, okay? So that's all we're doing with fractions today. So that's pretty easy. We have a numerator, we have a fraction bar, we have a denominator. The numerator tells us the equal parts that were used. The denominator tells us how many equal parts we had altogether. We can divide a whole or a group into fractions. Bam! That was our fractions for today. And I bet there's not a single person who says, what? I don't get it. If you don't get it, then go back on the video and watch it again and listen really, 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 really closely, okay? And I am pretty doggone sure that you will get it. But let's go ahead and look on page 51. Get your math book out. Put your name and date at the top. Tear your page out. You can pause the video while you're doing that. Okay, so in section 1, we're going to read each fraction and then write the names of the terms for just for letter A there, okay? So, and we have 4 over 5. So that would be read 4/5 is how we would read it. And our 4 is the numerator, and our 5 is the denominator. That means our fraction would look like this. It's always easier for me to draw rectangles. I always use rectangles for my fractions. 1, 2, 3, 4. So there's 5. Pretend they're equal. 5 equal parts. And 4 of them were used. That would be 4/5. Okay? Alright, look at section letter B. How would we say 2 over 3? We would say 2/3. Okay? Letter D, how would we say 1 over 2? 1/2. Letter E, how would we say 3 over 4? 3/4. And letter F, how would we say 7 over 8? We would say 7/8. Good job. All right, look at section 2. It says give the fraction for the part that is red. Decide if the fraction tells a part of a whole or part of a group, and then read each fraction. All right, so first we have to see how many parts, equal parts, that circle is divided into. That will be our denominator. So how many equal parts do we have? We have 5. And then how many parts are red? 2. So our fraction would be 2 over 5. And is that a whole or is that a group? Very good. That is a whole. Look at letter B. First, we have to see how many dots we have all together. How many dots do we have? We have 7. That's our denominator. And then how many of those dots are red? Very good. We have 3. So our fraction will be 3 over 7 is how we would write it. We would say it 3/7. And is that a whole or a group? Very good. It is a group. Look at letter C. How many pencils do we have all together? There are 3 of them. That's our denominator. And how many of them are red? 2. Very good. So we would write 2 over 3, and we would say it 2/3. And letter D. How many equal parts do we have there on our rectangle? Very good. We have 6. Pardon my phone, guys. And how many of them are red or are used? 1. Very good. So our fraction would be 1 over 6. Let me wait a second here. So our fraction would be 1 over 6. That's how we would write it. We would say it 1/6. And is that a whole or a group? It is a whole. Good job. All right, 3A. Write a fraction for each situation. Seth's uncle gave him $5. Seth spent $2. Write a fraction to show what part of the money he spent. So his uncle gave him 5. So that would be our denominator. So that would be the down number. And how much did he spend? 2. So our fraction would be 2 over 5, or 2/5 is how we would say it. And then it says, write another fraction to show what part he has left. So our denominator is still going to be 5 because that was the whole. And if he spent 2, how much does he have left? 3. So our fraction would be 3 over 5, or 3/5. Letter B. Carrie spent June, July, and August in Canada with the mission team from her church. What part of the year was she in Canada? Well, how many months do we have in a year? There's 12 months in a year, so that's our whole, 12. So that is your denominator, or your down number, the number on the bottom, denominator. And then how many months was she gone? June, July, August. So that is the numerator. So your fraction would be 3 over 12, or 3/12. All right, letter C. Miss Allen baked 3 pies. She cut the first pie into 2 pieces and gave 1 piece away. She cut the second pie into 3 pieces and gave 1 piece away. She cut the third pie into 4 pieces and gave 1 piece away. what part of each pie did she give away? So her first pie, she cut her first pie into 2 pieces and gave 1 part away. She cut her second pie into 3 pieces and gave 1 part away. And she cut her, am I doing this right, 2, 3, and 4? Yes, and she cut her last pie into 4 pieces and gave 1 piece away. Now watch, I'm gonna pretend I'm making her pie. So here's her first pie. She cut it into 2 pieces and gave 1 piece away. Here's her second pie. She cut it into 3 pieces and gave 1 piece away. And here's her last pie. She cut her last pie into 4 pieces and gave 1 piece away. So on your paper, write 1/2, 1/3, 1/4. And I want you, let's see, what does it say? It says what happened to the size of the fraction as the number of pieces increased. Here we have 1/2, here we have 1/4. As the number of pieces increased, 2 to 3 to 4, the pieces of our pies became smaller. Here we had 2 pieces. We had a pretty good piece right here. Then we had 3 pieces. A piece got a little bit smaller, and then by the time it's cut into 4ths, our piece got way, way smaller. So as the number of pieces increase, as your bottom number gets larger, the size of your piece will be smaller. Okay? Does that make sense? Look at letter D. Another day, Miss Allen baked 3 more pies. She cut the first pie into 6 pieces and gave 1 piece away. She cut the second pie into 6 pieces and gave 2 pieces away. She cut the third pie into 6 pieces and gave 3 pieces away. What part of each pie did she give away? All right, so let's look at this one. So she had her first pie, she cut into 6 pieces. There's our pieces, and she gave 1 piece away. Her second pie, she cut into 6 pieces, and she gave 2 of them away. Her next pie, she cut into 6 pieces, and she gave 3 pieces away. So let's see here. Here's our pie. Oh, I can't ever do this. That's going to be 8, isn't it? 1, 2, 3. No, 4. Okay. This way. There we go. So we have 1, 2. Oh my goodness gracious. Da-dun, 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 da-dun. Pretend those are equal. 1, 2, 3, 4, 5, 6. There we go. It's hard to do the 6s in a circle and make them look even. So I did it again. Pretend that's down there closer. All right, so for 1, 6, here we go. There's our pie. For 2, 6, here we go. There's our pie. For 3, 6, here we go. There is our pie. And it's saying, when the denominator remains the same and the numerator increases, what happens to the pie? The fractions increase in size. Okay? So when the numerator remains the same, or the, what? When the denominator remains the same, see down here the denominator changed. When the denominator remains the same, the numerator increases, the fraction increases in size. So here we go. So here was 1, 6, here was 2, 6, look at 3, 6. It's like, it should be half the pie if my things were divided right. So 3, 6, so as the numerators got larger, the pieces got larger as well, okay? But it's the opposite when your denominators get larger. Your pieces will be smaller, all right? Turn your books over to page 52. And on page 52, I want to do 4A with you. So we have 79,621 divided by 43. If our divisor is 43, what is our pretend divisor going to be? It is going to be 4. Very good. How many times will 4 go into 7? It'll go in there one time, but can 43 go into 7? Nope. So our 1 will have to be above the 9. And 3 times 1 is 3. And 1 times 4 is 4. We subtract. 9 minus 3 is 6. 7 minus 4 is 3. Is 36 smaller than 43? It is. We bring down our next digit, which is a 6. Nice straight columns, guys. How many times will 4 go into 36? It'll go in there 9 times, but 9 is going to be too big, so our estimating won't work this time. Let's do 8, all right? So we put our 8 straight above our 6 because that's the number we brought down. 8 times 3 is 24. Put 4 down, carry the 2. 8 times 4 is 32, plus 2 is 34. Subtract. 6 minus 4 is 2, and 6 minus 4 is 2. Is 22 smaller than our divisor 43? It is, so we bring down our next digit, which is a 2. How many times will 4 go into 22? It'll go in there 5 times. Very good. 5 times 3 is 15. Put 5 down, carry the 1. 5 times 4 is 20, plus 1 is 21. We subtract. We can't say 2 minus 5. Borrow from the 2, make it 1. 12 minus 5 is 7. And 1 minus 1 is 0. Is 7 smaller than our divisor 43? Absolutely. Bring down our last digit, which is a 1. And how many times will 4 go into 7? 4 will go into 7 one time. 3 times 1 is 3. 4 times 1 is 4. We subtract. We can't say 1 minus 3. Borrow from your 7, make it a 6. 11 minus 3 is 8. 6 minus 4 is 2. Is 28 smaller than our divisor? It is. Is there anything else to bring down? There is not. So our remainder is 28. Remainder 28. All right, look at letter B. In letter B, we have 50,143 divided by 69. In the number 69, what is our pretend divisor going to be? If our second digit is 5, 6, 7, 8, or 9, we add 1 to our first digit. 6 plus 1 is 7. Our pretend divisor will be 7. How many times will 7 go into 50? 7 times. 7 times 7 is 49. But back to our real divisor, can 69 go into 50? No, but it can go into 501. So we will put our 7 above the 1. Nice straight column. 9 times 7 is 63. Put 3 down, carry the 6. 7 times 6 is 42. Plus 6 is 48. Subtract. We can't say 1 minus 3. There's not anything here. Cross your 5 out, make it 4. Put your 1 in front of your 10. Now we can borrow from it and make it 9. Put 1 in front of our 1. 11 minus 3 is 8. 9 minus 8 is 1. Is 18 smaller than our divisor 69? It is. We bring down the next digit, which is a 4. Nice straight columns. How many times will 7 go into 18? 2 times. So our 2 goes above the 4. That's the number we brought down. 9 times 2 is 18. Put 8 down, carry the 1. 6 times 2 is 12. Plus 1 is 13. We can't say 4 minus 8. Borrow from your 8. Make it 7. 14 minus 8 is 6. 7 minus 3 is 4. Is 46 smaller than our divisor 69? It is. Bring down the last digit, which is a 3. How many times will 7 go into 46? 7 times 6 is 42. Put our 6 above the 3. 9 times 6 is 54. Put 4 down, carry the 5. 6 times 6 is 36. Plus 5 is 41.